Chemistry is the study of matter, what it's made of, how it changes, its properties. And so a part of matter is understanding its states. So here's the definition of matter. It's any substance that has mass and occupies volume. I always defer to the Bill Nye the Science Guy definition of matter, and matter is the stuff things are made of. And I don't know why that helps me, but it does. And we do need to know that matter exists in 3 states. So we'll talk about these states at just different times and in different contexts. But we have solid, liquid, and gas. And in the illustration here, they use water, which is a substance that we are very familiar with. So ice would be the solid form, and then liquid water, and then steam would be the gas form. Now, one thing I want you to consider as you are moving through this part of the chapter is not just about the states, but about the arrangement of the particles and how they influence some of the properties of each state. So what you'll notice here is in the solid, the particles are really close together. And they really would have the least amount of energy. Particles are still vibrating and doing things, but in terms of overall energy, there's the least in that. Then we get a little bit more separation. The particles are still close together, but they're getting a little bit farther apart. And we can see this because we know that liquid will flow, so those particles inside the liquid can move past each other. And then we have the gas phase, and the particles are really far apart relative to the size of the particles. So as you navigate this chapter, think about how the particles are when you're looking at the macroscopic, or the things that we see on the outside. So the characteristics of the different states are in this table, which is from the textbook. So just looking at shape, volume, and compressibility. Compressibility is can you push or squeeze the particles close together or closer together. So again, if you think about how the particles already are in that particular state, you might be able to then infer their compressibility. So if we look at a solid first, which is in this first column, their shape is fixed, their volume is fixed, and the compressibility is not significant. So you really cannot push the particles significantly closer together. The particles are already close to each other. Then we have liquid, so that's in the middle column. Now we know liquid shape is variable. The liquid will change shape depending on the container. Now it does not fill the container because it has a fixed volume. And I guess in this example, I always think about cooking in terms of how the shape can change, but the volume stays the same for a liquid. Because if you were cooking, and let's say you're making muffins and you have a cup of buttermilk that you're going to add to them. So a cup, which is an English measurement unit of measure that we wouldn't use in lab, but it still is a measurement of volume. So if I poured out a cup of buttermilk and then I'm going to put it into my bowl, the buttermilk doesn't stay in the same shape that it was in the measuring cup. It now takes on the shape of whatever part of the container it's in. So it maintains the 1 cup. It doesn't expand. We wouldn't like to cook if when we changed the containers, the volume changed. So the volume stays the same, but now the shape will change because the liquid, again, can flow and then move around each other. But again, because the particles are relatively close to each other, it does not have that much compression because they're still pretty close to each other. And then finally, there's a gas. And remember, gases are really, really far apart. They have the highest amount of energy in terms of their energy of their motion. And so gases just are in continuous motion. So their shape will change. They'll fill whatever container you put them in. Their volume will change, again, because they're going to fill the container. So they take on the shape and the volume of the container that you place them in. And they have significant compressibility because there is lots of space in a gas. And so compressibility would be the ability to press that space out and put the particles closer together. Now, normally, and you'll see on the next slide, when we change from solid to liquid to gas, or in the reverse direction, we either add heat or remove heat. So we normally think of changing states based on the temperature. But another thing that can change states is change in pressure. So if you have a gas and you compress it enough, it will actually change into a liquid. Now, this is not something we would do in our particular lab, but it is a possibility. Both pressure and temperature can impact the state. For us, it's usually going to be temperature. So let's take a look at some of the words associated with changing states and temperature. So this is, again, an illustration from your book. And if you look where I'm writing with my pen, from the left of the illustration to the right of the illustration, we're increasing the temperature. And so if you look at the states, here is ice, and then it goes through water, which would be liquid, and then water vapor, which would be gas. So we go from a solid, a liquid, to a gas. And what you need to do on this slide is review the words that are associated with the changes in state. So for example, you can see here, these are the two words that are associated between going from a solid to a liquid is melting, and a liquid to a solid is freezing. Then these are the two words associated with the transition between liquids and gas. So a liquid to a gas is vaporizing, and a gas to a liquid is condensing. And if it was something that said vaporization or condensation, that would also be equivalent to this. Now, two words that you may not be familiar with are when a solid over here goes directly to a gas here. So a solid directly to a gas is called sublimation. And then a gas directly to a solid is called deposition or deposition. Depends. I've heard people pronounce it both ways. I always think of the word deposit, like it's going down to a solid, so deposition. Interesting. So when I'm making this video, just yesterday, there was snow in some parts of Florida. And so the weather meteorologist was talking about things, and he was talking about the formation of snow in the atmosphere. So snow is actually the deposition of the water vapor. So the water vapor in the clouds goes directly to a snowflake. So directly from a vapor to a solid to form the snowflake. So I thought, okay, that's an example of this happening. He proceeded to say, then you know how snowflakes are so beautiful with those little crystal structures. If they go through the atmosphere and melt and then refreeze, they're no longer snowflakes. It's not snow. Then it becomes sleet. It's like little pieces of ice. So I guess I didn't realize that, but that was a little something that I heard on the news that caught my attention because we were talking about changes in state. You will also in lab be able to see iodine crystals sublime. We'll do a demonstration where we'll see them go from solid to the iodine vapor, and then we'll also have the iodine vapor deposit back to the iodine solid. So you will get an opportunity to see this phenomena, which is not that common under normal atmospheric conditions. So the big takeaway on this slide is to familiarize yourself or refamiliarize yourself with the words associated with changes in state. So here's a practice question. I encourage you to pause and then answer the question, and then I will give the answer. So go ahead and pause. So the question is, which physical state is described as having a variable shape and a fixed volume? So this would be liquid. Here's a second practice. Again, I would encourage you to pause, read the question, get an answer, and then I'll answer it. What is the term that describes a liquid to a gas? So liquid to a gas is vaporizing. And one thing you might do just to test yourself is try to remember what melting, sublimation, and condensation means. And a third practice, which of the following changes of state require cooling? Choose all that apply. I would pause and then we'll come back to it. I'll give you the answer. So the ones that require cooling, so this means we're going to remove heat from them to happen. The other one would require heating. So to remove heat, we need to remove heat to deposit, condensation, and freezing. So all of these are going, this is deposit is going from a gas back to a solid. Condensation is gas or a vapor to a liquid, and freezing is almost put solid, is liquid to a solid. The other three, melting, sublimation, and vaporizing, all require heat. As a practice, you might remind yourself what states, between what states those words represent. So the three states of matter might be very familiar to you, which is great. I want you to think about it in terms of the particles and how they're related to each other. And I also want you to be sure you're familiar with these words that describe different changes in state.